This is a reminder class, and the next sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class for your own security reasons. Kim, so sorry, not right now. If you, yeah, if there's the possibility that if you want to do that, we can get permission from your parents and stuff, but not during class. Sorry. You can email me though, and I can set that up, okay? Awesome. All right, guys. So we should be in our November 19th attendance ticket. So please go ahead and get that open up. Link is in the chat box as well as the password, all lowercase. I do need green checks all around, letting me know that you have that open and ready to go. Rating on Adrian, Adriana, Andres, Destiny, Edgar, Haley, Jeremy, Tucker, Johnny, Juliana, Vega, and Siva. Green checks, please. Looking good. Thank you so much. Love it, guys. All right, let's keep on going. So here is our schedule. Take a look at this, guys. No school Wednesday, Thursday, and Friday. Give me a big smiley face if that makes you happy. No school. I know we are on fall break. Thanksgiving is on Thursday, so we kind of have several days off. You get 5 days off, including Saturday and Sunday, so you'll get a nice long break. Definitely make sure you use it well. I know, I wish we had the week off too. I was so sad. I was like, why don't we have Monday and Tuesday off? But it's okay. We still get a lot of time off, so I'm still thankful for that. So today we are working on the gas laws lab. This is a pretty easy lab. It is a virtual one where you will need to be gathering your own data, but there's no Google involved. So super easy because we don't have to do any of those Google charts, which always makes our lives easier. And tomorrow we do have an extra credit game day, so we will make sure to end our day well as we go into fall break, because we will have an opportunity for some extra credit as long as you just come to class and participate in the game. So super easy, guys. Super easy week. So we've been talking about gas laws, studying gases, the laws that govern gases, pressure, temperature, and volume. And now we're going to go ahead and demonstrate one of the gas laws in the lab. So let's go ahead and take a look at that. So today's objective, as always with experiments, we should be able to design an experiment based on a hypothesis and analyze the resulting data. Specifically, this experiment is looking at the relationship between temperature and volume of gases. So that's where we are going today. Let's do a quick review of volume and temperature. So volume and temperature are directly related to each other. Temperature of gas directly proportional to volume when we're talking about a stretchy container like a balloon where there's constant pressure. So this means directly, right, means that if one increases, the other one also what? If one increases, the other one also does what? Tell me in the chat box. When we talk about the word directly proportional, if one increases, the other one also what? Yeah, it also increases, right? And the reason for this is because as we increase temperature, the molecules begin to move faster and faster. And as, like, imagine again, we're in a room and all of a sudden everybody starts sprinting around. If we're sprinting around, do we want to be close to each other or further away from each other? Tell me in the chat box. If we begin to move faster and faster, start sprinting around, do we want to be really close to people or do we want to start moving away from each other? What do you guys think? Yeah, we definitely want to get away from each other, right? That way we just don't have as much opportunity to run into each other, right? So we're going to expand away from each other, and the result is this is going to increase the volume of our container because, again, our container is stretchy, so it can get bigger in order to maintain constant pressure, right? We don't increase our pressure because we're just able to expand our container or our room, okay? So we can see that right here, right? In this example, we are increasing temperature. The molecules begin to go bing, 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 moving faster, faster, faster. That way they can move away from each other, they expand, the volume increases. And then the opposite is also true because, again, this is a direct relationship. If one decreases, the other one also what? If one decreases, the other one also does what? Again, it's a direct relationship. If one decreases, the other one also what? It also decreases. It does the same thing, right? Direct relationship means they do the same thing. Smiley faces if that makes sense. If one decreases, the other one does the same thing and also decreases. Cool, so the result is, right, if we decrease our temperature, the molecules begin to move slower, and just like you and I, if we're moving slower, we don't have to be as far away from each other, right? We can get closer, we can condense together, and as a result, our stretchy container is going to get smaller and decrease the volume. Okay, let's go ahead and make sure that makes sense. Go ahead, grab your whiteboard tools. Tell me which things over here match up with an increase versus a decrease in temperature, as long as we have constant pressure. Go ahead and match those up. Okay, I'm going to go ahead and pause this. Sorry, I'm going to go ahead and pause this because we started off very, very wrong, okay? please don't just copy what someone else does. Please make sure you think about this yourself, okay? Go ahead and start that again. Okay, let's go ahead and start that again. Increasing temperature, getting hotter, versus decreasing temperature, getting slower. Go ahead, match those up. There we go. Thank you. Yep, thanks for joining us, guys. Go ahead, get that link from the chat box. Try to be here a little bit more on time. That way you can get the link at the beginning of class. Looking good. All right, there we go. Lots of good answers. Awesome, awesome, awesome. I'm going to go ahead and pause in 5, 4, 3, 2, and 1. No worries, totally understand. I know you guys have a lot of other classes and stuff going on, so totally understand. Just, do your best. Try to get here early as possible. Cool. All right. I know, Tucker, right? There is the straight line tool if you don't want to have to do the drawing part. The straight line tool is that third line up from the bottom instead of using the pen. Sometimes that helps. Cool. All right, guys, let me go ahead and go over our answers here. So if we increase temperature, right, we get hotter. That's right. The molecules would get faster. And because they get faster, they want to move away from each other. And the result is it's going to push on our container and make our container get bigger. The volume increases, the gas expands. Smiley faces if that one makes sense. I'm going to go ahead and talk about decreasing temperature then. Decreasing temperature, yes, we're going to go ahead and get slower molecules. They slow down. As a result, they're going to go ahead and condense back together. They don't need to be as far away from each other. And so as a result, our volume is going to decrease. It's going to do the opposite. Okay, go ahead. This is number 1 in your attendance ticket. Go ahead, take a minute to do that. I do know it's a bit of a longer one, so take 1 minute, green checks when you have number 1 saved. Go, go, go. 20 seconds left. Work quickly. All right, just need a few more green checks. Angelina, Ciara, Elijah, Jackie, Johnny, Josh, Michael, and Ty. Green checks for number 1. Let me know that we're good on this. Have these all matched up. Perfect. Awesome. Okay, guys, so today's lab is a pretty simple lab. It has to do with this idea of balloons, which we already know really well what balloons do, right? We've seen it through the webcam. We've discussed it a whole bunch of times. So today we're just going to prove it with a simple lab. It's going to be super easy. So what we're taking a look at today is we're looking at how the temperature and volume of a balloon are related to each other, okay? So remember, we use our 5 senses to make observations. Tell me in the chat box really quickly, what are the 5 senses? Starting from the left to the right, what are the 5 senses? Tell me in the chat box, everyone. Go, go, go. Yep, we've got over here, yep, definitely sight. And then what do we have? Yep, we've got hearing, absolutely. What's after that? What do we got here? Everybody in the chat box, make sure you're participating. We've got sight, hearing. What else do we have? Yep, exactly, smell. And then what? Got a couple people who have this 4th one. What's this 4th one? Not hearing with your mouth, not exactly. What sense? Yes, taste, exactly. And last but not least, what's this one? I know there's a couple people in the chat box who already got this one. Yes, this one is touch. Awesome. Okay, so in real life, right, a lot of these senses we'd be using all at once. Obviously, right now we're going to go ahead and watch a video. So please, right, you're only going to be using maybe sight, hearing, probably not going to be using smelling, tasting, or touching because your computer wouldn't appreciate it. Oh, that's super cool, Haley. Awesome. That's a great way to look at science within everyday life, right? So let me go ahead. I'm going to go ahead and open up our video, and you guys are going to go ahead and make some observations about what's happening. So make sure you're ready to type once the video's over, so that you are ready to give me some observations. So sorry, let me go ahead and grab it really quickly. Got to make sure I have my right one here. All right, so here we go. Sharing this with you now on the whiteboard. Go ahead, give me a green check when you finish watching it. Go, go, go. All right, green checks if we finished watching it. Yeah, that's so funny, Ariana. I've literally never had to do an I'm not a robot thing with that. Yeah, okay guys, so tell me in the chat box, what observations did you make, right? We've got the left bowl, which is the hotter one, the right bowl, which is the colder one. What was happening to the balloon as it went from each bowl, as the kid put the balloon in the hot bowl versus the cold bowl? Okay, Ariana, no worries. Go ahead, watch that. Everyone else though in the chat box. Yeah, it was deflating and inflating, but in which one was it doing which, right? Awesome. I see Seha and Diego have some pretty similar answers, right? The hot water made the balloon expand, or it got bigger in the hot bowl. Yeah, what was happening in the cold bowl then? Tell me in the chat box. What was happening in the cold bowl? Awesome. I see an answer from Seha. I see Gabe and Haley typing, Tucker and Kendra and Sally typing. Again, what was happening in the cold bowl versus the hot bowl? Yeah, absolutely, right? In the cold bowl, it definitely decreased in size, right? So the hot bowl, it inflated, the cold bowl, it deflated. And that should totally make sense based on what we've just been talking about and based on what we talked about last week, right? The hot bowl, the gas molecules get faster, they try to move away, and so our balloon gets bigger to accommodate that. Whereas in the cold bowl, the molecules get slower, they don't need to move away from each other as much, and so it goes ahead and it goes back to a smaller size. Smiley face if that makes sense to you, right? So we've talked about the theory, and now we should totally be able to understand what it actually looks like, right? We can see what it actually looks like. Very cool. Okay, perfect, guys. Let's go ahead. I'm going to jump back over here, right? So some observations that we made, right, was that in the cold bowl, it deflated, got smaller, right? Whereas in the hot bowl, it inflated or got bigger. Right? Thumbs up if that's what we all agreed on, right? We all agreed on this. We were all able to see that. Thumbs up. Perfect, perfect, perfect. Okay, so let's go ahead. We're just going to go ahead and change this into a question. So again, what two things am I looking at? So the question today is, how are these two things related to each other? Tell me, what do you guys think? Ariana, here it is in the chat box. So what two things are we looking at being related? Tell me in the chat box. Think about hot and cold. What is that, right? What property is that? Hot and cold is what type of property? And then write the size of it. What type of property is that with gases? Tell me in the chat box. What two things are related? Good thing, yeah, right, Ariana? How are blank and blank? Yeah, so the first thing is right, temperature, right? Hot, cold, that's what we're talking about, temperature. So we're asking how are temperature and what else? The size is what of the gas? How are temperature and what related? Remember, we learned about a few different properties, right? We learned about temperature, pressure, volume, quantity. When we're talking about size, what type of property are we talking about? Temperature and what? Yeah, we're taking a look at the volume. So today we're looking at how are temperature and volume of a balloon related to each other. Okay, smiley faces if you guys feel good about that, if that makes sense about what our lab is looking at today. Okay, which again, we already know the answer. We're really just proving it to ourselves in this experiment. Cool. Okay, so let's go ahead and make some real life connections really quickly. Tell me in the chat box, is it easier to breathe while running if you're in warm air or cold air? Tell me what you guys think in the chat box. Easier to breathe while running in warm versus cold air? Looks like we're pretty divided. I would say it's actually easier to breathe in warm air. In cold air, you guys know how like it kind of hurts to breathe and you have to take shorter breaths. Smiley faces if that makes sense to you guys. I would say it's definitely easier to breathe in warm air. Do we agree with that? Disagree? Okay, cool. So I would definitely say, yeah, it's easier. It seems like it's much easier to actually breathe in warm air. Let's go ahead and figure out why this makes sense. This has to do with this law that we've been taking a look at, which again, this is Charles' law. Charles' law, which has to do with volume and temperature. Okay, so here's the equation for Charles' law, which we didn't really talk a whole bunch about this because we've just been looking at it conceptually, and you don't need to memorize this or anything. It's just this is what we're going to use today. Okay, so Kim, it's hard to breathe. Yeah, I'm like, if I'm running, it's hard to breathe no matter what temperature the air is. Okay. But Charles' law says that the volume of cold air divided by the temperature of cold air is going to be the volume of the warm air divided by the temperature of the warm air. Okay, so V over T equals V over T. So let's go ahead and figure out why is it a little bit harder to breathe in cold air. So let's imagine it's a cold day. It's only 14 degrees Fahrenheit. Okay, and we're trying to breathe. Oops, sorry, that's the wrong link, guys. That's our video. Here we go. Hi, Melissa. Here's our link for today. So it's a cold day, it's 14 degrees, and the temperature in your lungs is the temperature of your body, which your body is 98.6 degrees Fahrenheit. So we're just going to round, say 98 degrees, okay? Now, your lungs, when they're warm, can fill 500 milliliters of warm air, okay? Which is super easy on a warm day because the air outside of you is about the same temperature as the air in you, so it's pretty easy to do that, okay? Oh my gosh, that's crazy, Tucker. So the problem is though, when we're breathing in cold air, right, cold air expands as it hits your lungs. So you can't breathe in quite as much of the cold air, resulting in shorter breaths. So we're going to figure out how much of the cold air could we actually breathe in. Okay, so let me go ahead. I'm going to go ahead and let's actually fill this out. So the volume of cold air, that's what we're trying to figure out, right? We're trying to figure out what's the volume of cold air that we need to go ahead and breathe in. And I'm going to go ahead and divide it by the temperature of the cold air. Again, take a look at our problem here. What's the temperature of the cold air? Take a look at our problem here in orange. What's the temperature of the cold air? Awesome, awesome, awesome. I see an answer from Kim, from Michael, from Sally. Yeah, it's going to be 14 degrees Fahrenheit. So 14 degrees Fahrenheit. Awesome. And this is going to equal, over on the right, the volume of the warm air. So tell me, how much can our lungs fit of warm air? How much can our lungs fit of warm air? Again, take a look at our question over here. We're analyzing this, right? So looking at that. Awesome. I see an answer from Andrew. Right, so this was right here, our volume of our cold air. Right, now we're trying to figure out how much of warm air can our lungs fit. Still waiting on some more answers. Please make sure you're participating, working in the chat box. Working together as a class, not making other people do the heavy lifting for you, but being responsible for your own learning. Yeah, it's going to be 500 milliliters, right? So this right here, this 500 milliliters is the volume of the warm air. Sorry, this should be the temperature of the cold air, not the volume of the cold air. That's what we're trying to solve. Cool, so over here I would put on top, right, 500 milliliters. Awesome. And I'm dividing by that by the temperature of warm air, right? And in our lungs, again, what's the temperature of the air in our lungs? What's the temperature of the air in our lungs? Yeah, it's going to be 98 degrees Fahrenheit. Okay, so now all we need to do is we're going to go ahead and actually solve what the volume of cold air is that we can actually breathe in. So first things first, can I divide a variable by a number? Is that possible? Tell me in the chat box. Can I divide a letter by a number? Do I know how to do that? No, that's not possible yet. But can I divide two numbers by each other? Right, can I do 500 divided by 98? Yeah, definitely. Tell me in the chat box, grab a calculator from your computer or phone. What is 500 divided by 98? What is 500 divided by 98? Awesome, awesome, awesome. Getting some answers. I see an answer from Andrew. See an answer from Sally. Thank you. Kim, thank you. Yeah, so 500 divided by 98, right, is about 500 divided by 100, right? So we should get an answer around 5. So, yep, totally makes sense. 5.1 definitely looks like a good number to me, right? So 5.1, that's our answer here. Now, all I need to do is I'm trying to get the variable. I'm trying to get the volume of the cold air. So I need to get rid of whatever's next to that. So currently, what's next to it is dividing by 14. So how do I get rid of dividing by 14? By doing the opposite. What is the opposite of dividing by 14? Tell me in the chat box. What's the opposite of dividing by 14? Yeah, by multiplying, right? So I'm going to multiply by 14. And this right here is going to divide out. But whatever I do to one side, I also have to do where? Right? This is algebra. Whatever I do to one side, I also need to do where? Yeah, the other side of the equal side, right? So I'm going to also multiply by 14 on the other side. So now I've got my volume of cold air, the variable by itself, and on the other side, I just need to do what 5.1 times 14 is. So go ahead in the chat box, use your calculator to tell me what's 5.1 times 14. Oh, so many people already ready. Yeah, looking good. So this is going to be, so this is going to be 71.4 right here. Milliliters. Okay, so smiley faces, guys, if this makes sense here. Smiley faces, guys, if this makes sense. Okay, so the volume of the cold air that you breathe in, you can only breathe in about 71 milliliters of air, and then when it gets into your body, it's going to expand to that 500 milliliters, right? So on a warm day, we can just go ahead and breathe in all 500 milliliters of the warm air. Smiley faces if that makes sense. On a warm day, you can just breathe in the same amount of air, right? same amount of air that fits in your lungs. But on a cold day, you can actually only breathe in a little bit of the air because as it hits your lungs, it gets bigger, right? So it's going to expand a whole bunch in size to fill up your lungs, which means we're only getting so much oxygen because we're breathing in small breaths as it's going into our lungs. Give me a thumbs up if that makes sense, right? So cold air expands when it hits your lungs. So when we start off, we just can't breathe in as much, right? So we have to take shorter breaths. Cool. Okay, guys. So here's where we've been, right? We've talked about how balloons, when placed in cold environments, are going to shrink. And our question is, how does the temperature change affect the size or volume of the balloons? So let's go ahead and make a hypothesis. Let's say, again, if we are in a hotter environment, what's going to happen to the balloon? If we're in a hotter environment, what's going to happen to the balloon? If then, tell me in the chat box. Hotter environment, what happens to its size? Yeah, it's gonna expand or get what? The size will get what? No, it's not gonna blow up. Yeah, it'll get bigger though, right? Then the size will get bigger. Absolutely. And vice versa, you can also say if we're in a colder environment, what's gonna happen in a colder environment to that balloon? It'll deflate or the size will get what? Yeah, it'll get smaller. Absolutely. Okay, so that is our hypothesis here. And now we're going to go ahead and actually jump into our lab. So I'm going to send you the link to your lab report. If you're like Ariana and you have a hard time having multiple assignments open at once without your computer freaking out, just take pictures of what you see here so that you have it saved for later. But if you're able to open the lab, go ahead, open it up, give me a green check when you have it open, or give me a green check if you're ready to take pictures. Okay, go ahead, take 30 seconds, everyone, do that. I need green checks when it's open and started or when you're ready to take pictures. You can take pictures with your phone. You can also take screenshots on your computer if you know how to do that. Looking good. 20 seconds, get that open. 10 seconds. Adrian, Adriana, Sienna, Ciara, Demetrius, Destiny, Diego, Elijah, Gabe, Gabriel, Jacob, thank you, Jackie, Jeremy, Kyrie, Kim, Michael, Seha, Siva, Ty, Zoyo. I know. Totally fine, Ariana. Just give me a green check if you're good to take pictures, if you're ready to take your pictures of the slides. Totally fine, guys. Cool. All right, let's go ahead and get started with that, guys. So here's what's going to happen, okay? So again, our hypothesis is if a balloon's in a warmer environment, its size is going to increase. Or if a balloon's placed in a colder environment, its size will decrease. So in this case, right, in our experiment, we need to figure out what's the independent variable and the dependent variable in this experiment. Really important, guys. For question number 1, please don't put the definition of an independent or a dependent variable. I already know what the definition of an independent and a dependent variable is, right? I don't need to know that. I need to know what the variable is in this specific experiment. Smiley faces if this makes sense. Tell me what the actual variable is in this specific experiment. Don't just define it. That's so silly. Cool. Okay, so let's go ahead and talk about this. Remember, the beginning of a hypothesis, the if part, tells me the independent variable. So in this case, guys, what is our independent variable? What are we in charge of changing? What are we in charge of changing at the start of our experiment? Yeah, the temperature, right? So we're going to be changing the temperature. Okay, and we're going to be changing it in degrees Celsius. So that's our independent variable, what we are independently changing. Now our dependent variable is going to be the effect or the result or what we're measuring at the end of our experiment, also known as the second part of our hypothesis. Okay, so tell me, what is the second part of our hypothesis telling us the dependent variable is? The dependent variable. What are we measuring as a result? Yes, exactly. The size of the balloon, which in this case, we're going to actually be measuring the diameter. So the diameter or size of the balloon, and we're going to be measuring this in centimeters. Okay, diameter is related to the volume or the size of the balloon. So instead of actually measuring volume, because that's really hard to do, we're just going to measure the diameter. Smiley faces if that makes sense. Okay, diameter and volume, they're related to each other. So if one increases, we know the other one's also increasing. It's the same thing. Both of these are telling us size is increasing. Cool. Okay. This, guys, is your answer to number 1, right? So again, don't give me the definition, okay? I don't want the actual definition. I want the actual variables in for number 1. You can copy these exactly as you see them. That's totally fine because we're discussing these together, okay? So this is number 1. You guys have 1 minute to answer this or to take a picture, and then I need a green check from everybody. Green check when you've got a picture, green check when you've typed it in. Either one's fine. Again, if you're a slow typer, just take a picture, but I need green checks from everyone. So Alyssa, Ciara, Destiny, Edgar, Gabriel, Haley, Jacob, Tucker, Josh, Kyrie, Siva, Ty, and Zoe. Green checks if we're good on number 1 in our lab report. Again, you've either typed it in and saved it, or you've taken a picture of it. Green checks either way. Cool, let's keep on going. Okay guys, so here today we have a virtual laboratory, which means that you do need to actually virtually do this, and you're going to need to gather your own data, okay? Now, the thing is guys, I know sometimes it can be a little bit confusing when we do the labs, so you really need to watch the video for how to do this, and you need to make sure you watch it slowly, okay? So don't just rush through it and then say, I'm confused, I don't know how to do it, and then come to me and be like, I don't know what's going on. I really need you to do your best attempt to do it yourself. And then if you still need help, come to support session and I can work on it with you. Okay, smiley faces though, tell me in the chat box, what do we need to do before we ask for help? Before we ask for help, we need to do what? Tell me in the chat box. Yeah, we need to exactly take a look at the video, watch the instruction video carefully, slowly, do it ourselves, do our best to try it ourselves, and then if we're still confused, totally come to support. I will help you out, right? But it's really very difficult for me to help you out in support session if you haven't even tried, right? So always just try first. Always just try. Okay, so the link to the virtual lab is in question number 2. Thumbs up if you see that. The link to the virtual lab is in question number 2. It's right there for you. Okay, I'll show that to you in a moment, but really quickly, what you will see here in the virtual lab is there's 2 stations that we're going to be using. There's 3 of them, but we're only using station 1 and station 2. And at station 1 and station 2, they both have the same thing. They both have a jar with water in it. One of them is heated. Station 1 is heated. Station 2 is ice, so it's cold. And that's where we're going to be placing the balloons. Okay, we can see here we've got 3 balloons, so we're going to do each of these balloons. We're going to take measurements for each of these balloons, so you'll end up with 6 rows of data. So 3 hot balloons, 3 cold balloons. What you're going to be doing is you're going to be pumping up the balloon, okay? You're going to measure it at room temperature, which up here it'll tell you what your room temperature is, which your room temperature will most likely be different, okay? Your data should not look the same as mine. I do give you some example data, but don't use my data. Smiley faces if you understand. Do not use my data. Okay, because you'll have different room temperatures, you'll have different diameters, you'll have different temperatures of water. So don't use my data. It'll be really obvious that you've copied. Cool. So what we're going to do is we're going to blow up a balloon. We're going to measure it at room temperature. Then we're going to stick it into the container. So one hot is going into the hot container. Another one at station number 2 is going into the cold container. And then we wait for 4 minutes each. Okay, so we'll wait for 4 minutes. After they're either heated or cooled, we remeasure to see if they've gotten bigger or smaller. And in a total, this should take you about 12 minutes because you're going to do a hot one and a cold one at the same time. Smiley faces if you understand. So hot and cold, wait 4 minutes, hot and cold, wait for minutes, hot and cold, wait for minutes. Okay, and so in total, it takes about 12 minutes. And it's super easy, okay, not hard at all. Again, just watch the video. Okay, so what you're going to end up doing is you're going to be filling out these tables in question number 2. Again, don't copy my data. You should be putting your own data. So what we're going to see is we're going to fill out what the room temperature is. You will notice that this column all ends up being the same because your room temperature shouldn't change. Okay, thumbs up if you understand. Okay, so don't refresh it. Don't do one balloon, log out, and then go back in because it'll mess up your room temperature. So your room temperature should all be the same. Okay, so these ones should all be the same. Okay, and for the temperature of your hot balloon, okay, those temperatures should all be the same. And then the temperature for your cold balloon should all be the same, but obviously different from the hot balloon. Okay, smiley faces if you understand. So this one will be the same. And then the rest of the data should all be different, right? These diameters should all be different. Okay, so these are all going to be different. Okay, so again, if I see that your data, for some reason, all of your lines are exactly the same or something, or some things are changing that shouldn't be changing, you will get a 0 on it because A, I won't be able to tell what your data is saying, and B, it'll be very clear that you didn't actually do the experiment. Okay, so again, room temperatures, water for hot, water for cold, they should all be the same. Diameters should all be different because we're using different balloons. They might heat up and cool differently. Okay? All right, students, so at this point we're going to go over how to do questions 2 through 3 in the lab. Remember that after each step you should pause the video and complete the step and then do it in your own lab report, because if we're not pausing it does get confusing. So remember, play, pause, do the step, play, pause, do the step, and so on and so forth. You might want to actually take a look at the recording once through before actually doing it on your own, because it does show you how to only take 12 minutes to collect the data, assuming you go back and forth between the hot and the cold stations. So I will show you how to do that as well to kind of save your time. So here's what's going to happen. At this point, we've already answered question number 1 in the live class, or in the previous part of this recording, assuming you're watching the recording right now. So now we're going to go ahead and again move on to question 2 and 3. So we're going to go ahead and click where it says click here to open up the Gas Laws Virtual Lab, since that is where you will be gathering the data. You will be needing to gather your own data. You should not copy my data here because my data is going to look different than your data. So please make sure that you do the lab on your own. If I see my own data, I will know that you copied, and as a result you will not get credit for that. So if it says to enable Adobe Flash, make sure you click on it and click allow to allow Adobe Flash. Sometimes you might see something that says this plugin should be updated. All you need to do is click where it says run Adobe Flash. This white little text right here, I can go ahead and expand that really quickly so we can kind of zoom into that. This white little text right here might not look like a button, but it is in fact a button. So you can click run Adobe Flash and open that up. Okay, so now we're going to go ahead and click Begin the Lab. Make sure you don't click View the Tutorial. Make sure that you instead click Begin the Lab, choose your gloves, and then you're going to go ahead and click on where it says Start. Okay, so now we have our lab open. It's going to go ahead and get loaded here, and you'll notice that there are a couple stations here. Today we're only using Station 1, which is going to be our hot water experiment, and then if you scroll over to the right you'll see station number 2, which is going to be our cold water experiment, and you'll ignore station number 3. So we're not doing anything with station number 3 today, so just stations number 1 and number 2. Okay, so let's go ahead and go over how we are going to do this experiment. So some things here that you need to be able to see. Okay, so here we have a timer, which we will use to measure the amount of time that it takes for us to wait for the balloon to increase or decrease in size. Here we have a pump to blow up the balloon. We have the container where there's either hot water or cold water. In this case, the red balloons are the hot water, and over here the green balloons are for the cold water. You can see ice over here, and over here you can see a hot plate. Okay. And then we can also see calipers, which will be used to measure the balloon, and the room temperature is up here. Okay, so let's go ahead and take a look at our data table. So what we need here first is for the heated balloon, which is going to be at station number 1, we're going to write down the room temperature. Now, you will notice that I said up here, every one of these colored rows should look different except for the temperatures. The temperatures should be the same because your room temperature shouldn't change and your water temperature should not change. If they were to change, for example, if you were to refresh this, you would need to redo it because we do need, in order for these trials to be consistent, we do need the room temperatures and the water temperatures to always be the same. So for here, our room temperature is going to be 19.8 for each of these trials. So I'm going to make sure I put 19.8 in each of these columns. And while I'm at it, again, assuming that you're not refreshing, you should not refresh the page at any point or restart it. Then over here for our cold water experiment, the room temperature is also 19.8. Should be the same. So again, the temperature for the room should be the same, top and bottom for both of these. Now, the next thing that we want to do is we do want to measure our water temperature, because again, the water temperature for the hot balloon will be the same, and then the water temperature for the cold balloon will be a different temperature, but all of these 3 rows will be the same still. Okay, so I'm going to go ahead and take the lid off of the container here. Okay, so just pop that off and drop that to the side. And right here we have a thermometer. So I'm going to go ahead and pick up the thermometer and drop it into our container here. Wait for it to equilibrate, come to size, and come to temperature. And you can see right here that the water temperature for me is going to be 50 degrees. Again, the water temperature should be the same for all three of our hot water trials, so our heated balloon trials. So I'm going to put in 50 for each of these columns, for each of these rows in this column. So again, room temperature, water temperature should be the same here. Okay, so I'm going to go ahead and zoom out of that. And now what we can do is we can go ahead and actually let's see here, we can go ahead and actually get started with our balloons. So to blow up a balloon, you're going to go ahead, grab your first balloon, stick it on to the pump here, just click, and then go ahead and wait until you're kind of hover over this to make a C shape with your hand. Click that, and that's going to automatically blow up your balloon for you. Okay. When it stops blowing up, you can go ahead and just click on the balloon, and that'll pick the balloon up. And you're going to go ahead and measure it at room temperature. So we're going to measure it at its current temperature right now. Okay, so we can go ahead and just click within the calipers, and that'll drop it in for you. And then all you need to do is you need to go ahead and click and drag. Click it and then drag it to size, and you're going to drag it in until it reaches the edge of the balloon. We're going to go ahead and zoom in and measure this, and you might need to even zoom in on your browser to see this. It's kind of tiny, but for me this is going to be 15 inches and oh sorry, this is centimeters. This is going to be 2 dashes past 15, so this would be 15.2 centimeters. 15.2. Remember, the dashes are the points, right? So 2 dashes, 0.2. Let me go ahead and zoom back out here. Okay, so now I have my balloon here. Sorry, I'm going to continue zooming out. I have my balloon. I'm going to go ahead and pick it up from the calipers. Okay, so now I have my balloon. And now I'm going to go ahead and put it in the hot water, and I'm going to allow it to heat for 4 minutes. Okay, so we're going to go ahead and just click inside of here. Okay, and then go ahead and put the lid back on so it's fully in there, and then click start to start your timer. Okay, so that's going to go for 4 minutes. Now while that's happening, because again eventually I'm going to get my diameter after heating here after 4 minutes, while that's happening I'm going to go ahead and do my cold water trial so that I'm not wasting time. I can just go back and forth. So in total this should take you about 12 minutes to do, going back and forth. Okay, so we're going to go ahead and go over to our cold water trial while that hot water one is still going. And same thing here. Okay, so again, our room temperature is still the same. All three of those columns should be the same. And we need to go ahead and figure out what the water temperature is for the cold water. And again, for the cold water, it should be all of the same this should be all of the same 3 temperatures, because our cold water needs to always be the same for each of our balloon trials. So I'm going to go ahead and grab this thermometer and stick it into here. Just click and stick it in there. And that's going to be 5 degrees. Okay, so if I zoom in, you can see that says 5 degrees. So here, again, all of my 3 cold trials should have the same cold water, which is 5 degrees Celsius. Okay, so that's good. I'm going to go ahead and take that thermometer out, drop it on the counter. And now we need to go ahead and do the same exact thing. We're going to go ahead and blow up our balloon, measure it, and then stick it in the cold water for 4 minutes. So go ahead, grab this balloon, stick it onto the pump. Go ahead and click the handle of the pump to blow it up. Wait till it blows up completely. It'll stop on its own. And then go ahead, click the balloon, go over to the calipers, just kind of hold it in the center of the calipers and click, and it'll automatically put it in for you. Click on this edge and then drag it over to the left until it reaches the edge of the balloon. And we're going to zoom in again. We might need to zoom in a whole bunch here. So for me, this says about 6 dashes past 15, so this would be 15.6. Now what you will notice is the diameter at room temperature for each of the balloons is different, right? So I'm not copying any of this, right? I should measure each of the balloons on their own. So we're going to measure each of the 3 red balloons, and then each of the 3 green balloons. All of these rows right here should be different. If I see that they're all the same, I'm going to assume that you just copied your data 3 times, and that's cheating, so you won't get credit for it. So again, we should see that there should be some differences in each of the diameters of each of the balloons. Okay? A couple of them might be the same, but for the most part, they should all be different so that I know you're not cheating. Cool. Okay, so we're going to go ahead and we have this, so just click on your balloon to grab it, and then you're going to go ahead and drop it in the cold water. Grab the lid, put the lid on, make sure you put the lid in, and then go ahead and click start. And again, that's going to go for 4 minutes, and while that's happening, I'm going to go ahead and jump back over to my red balloon, and I'm going to go ahead and get my data after heating for my red balloon. So I'm going to scroll back over here, and I'm going to go ahead and wait until this hits 0 to do this. Okay, so I'm going to go ahead and wait until this hits 0, but I do want to explain this, right? So currently we have our first red balloon, and currently we have our first green balloon going. So you can see I have my first red balloon for the heated trials, and my first green balloon for the cold trials, okay, the cooled trials. Okay, so we will be doing 2 more balloons for each side, right? So you will be blowing up this second balloon and measuring it. You will be blowing up this third balloon and measuring it. And again, that data is going to go in row number 2 and row number 3 here. So the second balloon diameter goes here. The third balloon diameter goes here. And keep in mind, guys, again, all 3 of these numbers should probably be different. If I see they're all the same, I will assume that you're copying because none of the balloons are exactly the same. Okay, so perfect. We have this now, so I'm going to go ahead. This is at 0, so I'm good. So I'm going to go ahead and I can just click reset to reset that clock back to 4. But I'm going to go ahead, take the lid off, and drop it to the side. Grab this red balloon. Again, stick it back into the calipers now that it's heated. Click on the edge and drag it over. And again, zoom in a whole bunch to make sure I can actually see the measurement. Okay, so I'm going to go ahead and, oops. Sorry, let me zoom in here too. Okay, guys. So zooming in here, I can see that this has increased to about 9 dashes past 15. So that would be 15.9. So I'm going to fill out the first row because this is the first balloon. And the diameter after heating should be 15.9. Okay, so we can see that after heating, my first data point shows that the balloon got larger, right? It went from 15.2 at room temperature, got hotter, and went to 15.9 centimeters. It got bigger. Okay, so that's really important because we're going to need to know that for our conclusion. Okay, question number 3 is our conclusion. All right, so I'm good on that one. I'm going to go ahead and drop this balloon to the side because I no longer need it. So just drop it over to the side. And we're going to go ahead and blow up our second balloon and set up our second trial, right? So I'm going to grab the second balloon, blow this up. And again, my cool water experiment is still going over on the right. So I'm still waiting for number 1 for the cool water to work as well. Click on the balloon, place it in the calipers, measure it. And again, this is the room temperature balloon, room temperature diameter of the second balloon. So here's where I'm filling out the second balloon. So zooming in here, zooming in. I can see that this one is a diameter of 16.2. Again, these 3 numbers should be different because we're measuring different balloons, okay? The temperatures are the same, but the diameters are changing because we're using different balloons, okay? Perfect. So I'm going to go ahead and take that balloon that I've measured, and now I just need to put it in the hot water again. So I'm going to go ahead, stick it in the hot water, put the lid on, and again, I've reset this, so now I can start it again, and it's at 4 minutes. Okay, so now we're waiting for our second one to heat up and measure the diameter after heating. But now my cool one should be about ready. So I'm going over to my cool one, which is just about ready. And again, after this, we will be doing number 2 and number 3. And that will make sure that all of these are done within about 12 minutes of time. So it's a super easy lab. You just need to wait 12 minutes to make sure everything gets done. Okay, so pop the lid off. Now that the timer's at 0, we can reset that as well to get it ready for the next one. Grab our balloon. We can see our balloon kind of has these lines on it showing that it's been shrunken a little bit, so we should expect a smaller diameter. Drop it into our calipers. Grab the calipers, move them in. I'm going to go ahead and zoom in for you so that you can see this. Okay, and right here it's showing that my diameter here is about 15.3. So 15.3, which we are seeing that for my, and again, this is for the cooled balloon. So it's number 1 under the cool table, the ice table, okay? So here we can see that at room temperature, the balloon started at 15.6, and then when put in cold water, it actually shrunk down to 15.3. So that's very different from our hot balloon. Our hot balloon went from 15.2 at room temperature to 15.9, getting bigger after heating. The cold one got smaller. Okay, that's important again for our conclusion. Okay, so I'm going to zoom out of here, and I'm going to go ahead and drop this first balloon over to the side because I don't need it anymore. So just drop it over to the side. And again, guys, we still have our second one going over for our heated balloon, but while we're waiting, let's set up our second one for the cold balloon. So grab your second cold balloon, put it on the pump it up. When it's ready, click on it. So we're going to go ahead and click on it, place it in the calipers, click on the calipers, measure these, and again, your data should all be different because you have different balloons and you're also going to have different temperatures. So you will have different room temperatures than me, you may have different water temperatures than me. So all of your data here should look different, okay? It shouldn't be exactly the same. All right, so sorry, let me zoom in on here to see this. So my second green balloon is 13.5. Okay, so again, you can see the diameter is different at room temperature because it's a totally different balloon. Okay, so I'm going to go ahead, zoom out of that, and we're ready now to go ahead. Oops, drop that. We're ready now to go ahead, put this balloon into our cold water, put the lid on. And again, I've reset my timer, so I'm going to start it, and it should start counting down from 4 minutes. So now we have our second balloon in here for our cold one. We can go back to our warm one and do the warm one, okay? So when this hits 1 minute, we'll measure the diameter of the warm balloon, the hot balloon, again, after heating, and place that data here. Once that's done, we're going to set up our third balloon. Here's our third balloon. We'll blow it up. We'll measure it before, put it in, heat it for 4 minutes, go back and do our cold one. Okay, so we'll go back over here, do our second cold one, right? Take that out, measure it after cooling, and then set up our third cold one. So you're going to go back and forth, and eventually you should have all 3 of these data tables filled out. Okay, I'm not going to go ahead and show that to you because, again, you do need to collect your own data, and I don't want you to tempt you to copy my data because that's cheating, right? So I do expect you to go ahead and be able to do number 2 and number 3 completely on your own, which again, you should do all 3 of these hot ones and all 3 of these cold ones on your own because they are completely different balloons. Okay, and you're gonna have completely different data than me. Okay, so don't copy my data. Make sure you do all 6 balloons on your own. Okay, so at that point, we have all of our data, and now we just need to answer question number 3. So based on our results, did our data support or disprove the hypothesis? And making sure we include actual numbers and data. So your answer needs to include actual numbers from our data tables up here, otherwise you will get a 0 on the entire question. Okay, if I don't see all the numbers I need to see, you will get a 0. Okay, so we're going to write sentences here. We're not just going to put our numbers, we're going to write sentences with our numbers. So up here, remember our hypothesis was that if a balloon's placed in a warmer environment, its size will increase, or vice versa, if a balloon is placed in a cold environment, its size will decrease. And based on my data up here, I can see that that's supported, right? You should double check your own data to make sure it supports our hypothesis, but based on what I'm seeing for our data so far, my data, not yours, my data so far, this is actually supported, right? Hot water, it got bigger. Cold water, it got smaller. Okay, so we're going to go ahead and say up here that this is supported. Okay, and then I'm going to explain why my results prove this, okay, including actual numbers, actual sentences to say this, okay? So my results prove this because for the heated balloon, it went from a size of 15.2 centimeters at room temperature to 15.9 centimeters when heated to 50 degrees Celsius. Okay, right. Now again, you should have totally different data, so you should be seeing that you're filling in your own numbers, which means it increased in volume, right? It got bigger. Okay, so you can totally use this same sentence frame, but you need to make sure that you include your own data. Okay, so you should include your own data right here. Okay. Cool. Now you also need to say the opposite part because we had the other part of our data table and our hypothesis. For the cooled balloon, it went from, in my data, again yours will be different, but my data, it went from 15.6 centimeters at room temperature to 15.3 centimeters at when cooled to 5 degrees Celsius, which means it decreased in volume. Okay. All right. And so that, again, you're going to go ahead and put your own data in. Okay. Okay, and you guys can use any of your data points, right? If you want to show it with balloon 2 from each of the tables or balloon 3 from each of the tables, that's totally fine as well. But you do need to make sure you choose one of your hot balloons and one of your cold balloons to fill the sun at degrees Celsius, okay? So again, if it supports it, this is exactly what your conclusion should look like. Just make sure you fill in your own data, okay? So as long as I see your own data is in here, I'll say that this is in your own words, and I'll give you your credit for that, okay? So that's everything that you need for this. Go ahead and make sure that you submit this. And then you should be all set to go. So submit it and make sure, again, you click submit so that it's completely done. Okay, so thanks so much, guys, and I will see you later. So I'm going to go ahead and actually end class now, right? So here was our here was our objective for today, and we're going to go ahead, again, watch the video, do the lab. It'll take you about 12 minutes, all right? Plus a few more to do the conclusion, so like 20 minutes in total, super easy. It is due by 4 o'clock, but again, I care more about you doing it correctly, so if you don't have time to do it right away, just get it done later on, turn it in so it's correct, right? You'll still get full credit even if it's a little bit late, okay? And here's your last word, everyone, okay? That's all we need for today, and I will see you guys later. Let me know if you have any questions. Bye, everyone. See you tomorrow.